Adaptive control systems can adjust in real time to changing parameters. A common example can be seen with traffic lights. Historically, traffic lights operated on fixed timers programmed by officials who used studies of traffic patterns to determine optimal timing. This created bottlenecks and other problems as traffic patterns shifted over the course of time. When a traffic light uses adaptive control, a computer tracks the traffic in real time and determines the timing of the lights to keep traffic moving optimally. Such systems have widespread applications in the management of a variety of processes where parameters may change, sometimes in unpredictable ways. Aircraft, for example, can utilize adaptive control systems as part of an autopilot program to adjust both to predictable variables, like reductions in weight as the plane burns fuel, and unexpected events like turbulence. Manufacturing processes can also involve changing parameters on the production floor, as can control systems used for scientific experiments and research application. This varies from a fixed control system where a programmer needs to be knowledgeable about the system and the parameters that might be encountered. Programmers have to predict a variety of possible outcomes and structure them into the program so it can respond. By contrast, adaptive control systems don't need to be programmed with instructions for different situations, because they can read and respond to them independently. This also allows them to deal with a far wider scope of problems, because any number of changing variables can be addressed. Using adaptive control systems can allow for more efficiency, which results in cost savings in the long term. In manufacturing, for instance, programs don't have to be bounded to compensate for the worst-case scenario. If a problem develops in production, the adaptive control system can compensate for the issue. Thus, production lines aren't slowed by programming limitations. Likewise, drivers may not sit in a turning lane for 15 minutes in the middle of the night, waiting for a timer to change. Advances in computing have led to significant improvements in adaptive control systems. New designs are more intuitive and capable of more complex tasks than their predecessors. Testing also allows researchers to identify weak points and areas of needed improvement so they can build the next generation of systems to make them more reliable. Costs also drop with each iteration, making it possible to integrate the technology into more products and settings.